And then I'm going to share my screen and go to the desktop here, and we'll share that. And then we'll flip over to my presentation software. And this is the last of the material that we're going to cover, and hopefully I'll get through all of it tonight. I kind of rehearsed it uh, last night, and I was able to get through it in 30 minutes. Of course, I like to talk too, so I wasn't talking. I was just kind of reading it in my mind. So we're on Module 9. This is talking about safety. We'll talk about electrical safety, managing radio frequencies in your station, RF interference, or called radio frequency interference, radio frequency exposure, mechanical safety, and so that's what we'll cover. And I'm not going to stay on this slide, but like I've said before, ham radio is a hobby of 1,000 hobbies. You can find something that's of interest to you. Kind of wanted to show you the aurora borealis at my farm happened last week. I don't know, Joe, if you got to see any of it from Florida or not, but here in Kentucky, it was very beautiful. And I was able to get out and grab some pictures of that. But that's from a solar flare striking the upper atmosphere and causing the uh, light to show up. The northern lights to show up this far south. And here's another one. I believe that one was actually as it was getting started, but you can see how beautiful that is. So,
Wow. Thank you for showing.
oh, you're welcome. Let me back that up. But yeah, it was amazing. And they said this was on the first night that they said we could see the northern lights, and I was able to capture several photos of it. But then the second night, they said it was going to be better, but in my part of the country, I didn't see anything. So, so let's talk about electrical current, electrical injuries. Electrical current through the body, as we know, can disrupt electrical functions of our cells. It can cause involuntary muscle contractions. Large currents can burn the skin and heat tissue. Here's some effects. This is a chart. Below 1 milliampere, generally not, you can't feel it. About 1 milliampere, it's a faint tingle. 5 milliamps, slight shock felt, not painful. Average individual, you can let go of it. Between 6 and 25 milliamps for women and 9 and 30 milliamps for men, it's a painful shock, loss of muscular use, freezing current, you can't let go. 50 to 100 milliamps, extreme pain, respiratory arrest, muscular contractions, death is possible. 1,000 to 4,300 milliamps can cause your heart to stop, and 10,000 milliamps, cardiac arrest, severe burns, and death probable. Now, most of this, I've never been shocked by DC current. This is talking about AC current. Uh, I've been burned by DC current, but not any electrical hazard like that. When you're working with the power on, which I don't advise you to do, always, especially nowadays with electrical systems, it's very easy to turn things off, especially if you're working on household current. Go to that breaker panel and turn that breaker off and check and double check. And I should have brought one, but they make these little testers that are not very expensive that you can hold up. Like, let's say you're working on an outlet or a switch, you can hold that tester up near that switch or outlet, and it will let you know whether there's power on it. And you want to make sure that it's off. So we'll talk about it being on, but my advice is make sure everything's off. If you're working with it on, keep one hand in your pocket, wear insulating shoes, never bypass a safety interlock during testing, make sure capacitors are discharged. I will have to tell you, as a kid growing up, I kind of like to take things apart, and I had this little camera, and it had a built-in flash, and it quit working. So I thought I'm going to take this apart, and see what's in it. And it had a capacitor in it. And as a kid, I didn't know what a capacitor was at the time, so I shorted it with a screwdriver, and it burnt the tip off the screwdriver. So that's how powerful capacitors can be. So you will always want to make sure the discharge. Keep metal objects clear of storage battery terminals. Even a 12-volt battery, you can burn up a metal piece of metal with it. It can melt copper, so you have to be careful with batteries that way. Avoid working on equipment with battery connected, especially modern day equipment, because if you short something out with the battery, it could also burn up your equipment. And some of our radios are very expensive. Remove unnecessary jewelry from your hands and avoid working alone, whether it's on battery stuff or on AC current. Uh, when we talk about AC or alternating current safety grounding, the safety ground is a connection to the power system's ground reference connection in your main electrical service box. I know we probably all have some kind of electrical box in our home. Usually it's got a door on it. You open it up and you see all these breakers that you can turn on and off. But behind that, if you take that door off, you'll see a bunch of wire. You'll see black wires usually are connected to the breakers that you turn on and off. That's the hot wire. You'll see the white wire, and it's usually connected to a strip. And then you might see a bare copper wire, and it's connected to a bar. Those wires are connected to the bar. And that safety ground it's talking about here will literally run from that bar through the wall somewhere out to side your house, and there's a big grounding rod that's probably about 6 or 8 feet long that's been driven down in the ground, and that copper wire is attached to that, and it'll be a big, thick, heavy copper wire, and that's your safety ground. So if there's a short or something, it's going to take that electricity to the ground, literally the earth outside your home. The ground connection causes a fuse or circuit breaker to remove power from the equipment. So if you short out your outlet, that connection causes the circuit breaker to trip. Or like in my house, sometimes I forget and I run the coffee pot and the microwave and the pancake maker or anything, too many things at once, and I'm pulling too much current, and your breaker will trip as well. Grounding guidelines. Use 3-wire power cords and plugs. All modern homes now do that. Homes built back in the 50s and 60s only had two prong term plugs. You didn't have that third grounding plug in the outlet. But modern day homes will use 3-wire power cords and plugs. Make sure all equipment has a connection to the ground, and we're literally talking about the earth outside. Use ground fault circuit interrupter circuit breakers or outlets when you can. Verify AC wiring is done properly. So if you build a home, nowadays there will be an inspector from the electrical company that will come and look at the wiring in the home and make sure that it's been done properly, or they won't connect you to the grid. Never replace a fuse or circuit breaker with one of a larger size. And I think we've talked about this before, but if you put a fuse or a circuit breaker that's bigger than the one the circuit originally had, it can cause excessive power in the circuit and can cause a fire or worse. Well, fire is the worst thing. So it could burn up an appliance. So you want to make sure you replace it with whatever rating it was before. And don't overload single outlet. I know it's tempting to put one. You can go to Walmart and buy these little multi-plugs and put them on an outlet. Just be careful with that, and don't use high draw appliances on a multiple outlet like that adapter that goes on a single outlet. All right, we're still talking about grounding. When wiring circuits, be sure to follow the U.S. standard. And when I built my home, I went to the electrical company. They gave me a book on electrical standards, and I actually wired my own home way back 40 some odd years ago. And I followed that electrical code. The inspector came out and I passed because I'm sitting here now. So the electrical standard in AC, alternating current, for home, hot or the black wire, occasionally it could be red. You'll see red usually in DC wiring as being the hot wire. Neutral will be the white wire. Safety or equipment ground will either be green or it will be a bare copper wire. So that's the general standard. Now, when you go to using battery and DC current, red is usually your hot wire and black is usually the negative. So it's kind of reverse when you're working with DC current. Use cable and wire sufficiently rated for the expected current load, and that goes for either AC current or DC current. You don't want to use too small of a wire because even in a DC current, if it's too small, it will overheat. It will either melt the wire or cause a direct short, so you got to be careful with that. Use the proper size fuses and circuit breakers. Be sure fuses or circuit breakers are installed in series with a hot conductor or conductors. So going back to your breaker panel, that in your home, that breaker that you flip the switch off and on, it has a black wire going into it, and it connects to the power bus that's coming from outside your home. So it's in series with it. And here is current carrying capability of some common wire sizes. We're talking gauges of wire here, 14 gauge allowable current. And it tells you here, it's a little chart there, maximum fuse or circuit breaker, like on 12 gauge wire, which is common. 12 and 14 gauge wire is common in homes. Unfortunately, because of the price of things, most homes now are wired with 12 gauge on just certain parts, like a bedroom would be on 14 gauge. You might have 12 gauge wire in your kitchen, and the allowable current in amps would be 25 for 12 gauge and 20 for 14 gauge. And then here's what your circuit breaker would carry: 20 amps or 15 amps. I'm having to look over because it kind of blocks what I'm looking at here. So you have to, like, if you have a breaker that, and they do go bad from time to time, if a breaker goes bad and it's on a 14 gauge wire and it's a 15 amp, you don't want to go take a 20 amp and put it on there because that can cause, again, a fire hazard. All right, lightning protection. That's intended to provide protection for your home. Starting at your antennas, all towers, masts, and antenna mounts should be grounded according to local building and electrical codes. Connections are made at the tower base through a large diameter wire to a ground rod. So if you've got a vertical tower, you want to have a large diameter wire, like a number 6 gauge or higher. The smaller the number, the larger the wire. So 14 gauge is very small. 6 gauge is going to be very thick. You want to have that connected to a ground wire if you're using a tower for your antenna. Now, some of us, like myself, I'm using a dipole or an end-fed halfway antenna, which is a wire stretched across my yard. It's kind of hard to ground that. So usually what I make sure is I've got everything disconnected during a storm, and I can even take my antenna down if I know it's going to be pretty bad. Ground connections should be as short and direct as possible. Avoid sharp bends. Now, I'm going to tell you that's a test question. You want them short and as direct as possible, and you don't want to have any sharp bends in your grounding connection. Use lightning arresters grounded to a common plate that is in turn connected to a nearby external ground. So if you can, put your lightning arresters on your coax and then make sure they're connected to a common plate that is to a nearby external ground. All ground rods and earth connection must be bonded together with heavy wire or a flat metal strap, usually made out of copper. All right, we got some practice questions. What health hazard is represented by an electrical current flowing through the body? It may cause injury by heating tissue. It may disrupt electrical functions of cells. It may cause involuntary muscle contractions. All of these choices are correct.
All are correct.
All of them are correct. That is the right answer. What hazard exists in a power supply immediately after turning it off? Circulating currents in the DC filter. That's no. Leakage flux in the power transformer. Voltage transients from kickback diodes, or charge stored in filter capacitors.
D.
It's going to be D, the capacitors, storing energy. And like I said, I had a little old camera and I burnt the tip of a screwdriver, plus scared me to death. And I don't mess with capacitors. In the United States, what circuit does black wire insulation indicate in a 3-wire 120 volt cable? Now we're talking AC current here. Is it the neutral? Is it the hot wire? Is it the equipment ground? Or black insulation is never used?
Hot. B. B. Hot.
B. It's going to be B. It's going to be the hot wire. So that's correct. So when you're talking about AC current, your household current, black is the hot wire. The white wire will be your neutral, and your green or your bare copper is the equipment ground. What is a good way to guard against electrical shock at your station? Use 3-wire cords and plugs for all AC powered equipment. Connect all AC powered station equipment to a common safety ground. Install mechanical interlocks in high voltage circuits. And D, all these choices are correct.
D.
It's going to be D. All these choices are correct because 3-wire cords, we mentioned that, connect all AC powered equipment to a common safety ground. And mechanical interlocks in high voltage circuits, that's just where you can lock the circuit out and prevent somebody from accidentally turning it on while you're working on it. So the answer there is going to be D. And even if you didn't know C, we mentioned 3-wire cords and plugs for AC and all AC powered station equipment to a common safety ground. We did talk about these two. So if you get 2, if you know 2, and you're not sure about the third one because D, all these choices are correct, you can automatically assume that that's going to be the answer. Where should a fuse or circuit breaker be installed in a 120 volt AC powered circuit? So this is going back, we're talking about household current, in series with the hot conductor only, in series with the hot neutral conductors, in parallel with the hot conductor only, in parallel with the hot neutral conductors. And the answer here, again, the hot wire is what's carrying the current in an AC, so it's always in series with the hot conductor only. So the answer is A. Where should a lightning arrestor be installed in a coaxial feed line? At the output connector of the transceiver, at the antenna feed point, at the AC power service panel, on a grounded plane near where feed lines enter the building. And I don't know that we mentioned it, but it's going to be D, on the grounded plane near where feed lines enter the building. I think we did mention that.
Yep.
Okay. So the answer is D there. What should be done to all external ground rods or earth connections? Waterproof them with silicone caulk or electrical tape. Keep them as far apart as possible. That one we can take out. Bond them together with heavy wire or conductive strap. Tune them for resonance on the lowest frequency of operation. So
Them
we
together with
which one?
bond them together with heavy wire and
Yes.
conductive strap.
Yes, the answer is going to be C there. So you want them all to act like a single ground. So if you've got several ground rods, you want to kind of put them all together with a heavy wire conductive strap. Which of the following is good practice when installing ground wires on a tower for lightning protection? Put a drip loop in the ground connection to prevent water damage to the ground system. Make sure all ground wire bends are right angles. Now, we know we don't need sharp bends, so we can take that one out. Ensure that the connections are short and direct, or D, all of these choices are correct. So we know that no right angle bends, so that automatically it's going to eliminate B and D. So
I'd say C.
C, ensure that all connections are short and direct. Which of the following is true when installing grounding connectors used for lightning protection? Use only non-insulated wire. Wires must be carefully routed with precise right angle bends. All right, we can scratch that one, but we don't want sharp bends. Sharp bends must be avoided. Common grounds must be avoided. Well, we want grounds, but I gave you the answer when I answered this one. You don't want sharp bends. So sharp bends must be avoided. So the answer is C. Which of the following establishes grounding requirements for an amateur radio tower or antenna? We're talking about organizations here. FCC Part 97 rules, local electrical codes, FAA tower lightning regulations, UL recommended practices.
Local electrical codes.
It'll be B, local electrical codes. All right, how do you manage radio frequency in your station? Your station wiring, feed lines, and power connections and other cables all pick up radio frequency from your transmitted signal. It is not practical to ground RF current in the same way as for AC power and lightning protection. Best approach is to bond all the equipment together. Keeps all your equipment at the same voltage so that RF current does not flow between the different pieces. RF current on cables and enclosures can cause audio distortion, erratic operation of computer equipment, and even RF burns. If you're touching your radio and you get a burn from it, then you've got something that's not properly grounded or you're getting some feedback. RF feedback via microphone cable can cause distorted transmitted audio. So if you're getting some kind of feedback and somebody's saying your audio's distorted, then something needs to be checked out on your equipment. Bond all metal equipment enclosures to a common RF ground bus. Use short, wide connectors such as copper flashing or strap or heavy solid wire. Solid strap is best because it presents the lowest impedance to radio frequency. Keep all connections, straps, and wires as short and as direct as possible. Connect the ground bus to your AC safety ground and any earth connections. Radio frequency interference and filters. Interference between appliances and ham radios called radio frequency interference. Filters are used to prevent unwanted signals from being radiated, keep unwanted signals from being received. AC power line filters keep RF signals from passing into or out of the equipment via the hot or neutral conductors of an AC power connection. As I've mentioned, I think in a couple of other classes, when my washing machine is running, I can't play radio because the RF frequencies coming from the washing machine make receiving signals unusable on the radio because I'm seeing the agitator moving back and forth on my radio on my screen, and I can hear it in the signals that I'm receiving. Now, one way I minimize that is I take some little magnetic. They're kind of like little caps, and I can put it on the power cord of the on the washing machine, or I can use a toroid, which is a metal ring, and I wrap the power cord through the toroid, and that minimizes some of the radio frequency coming out. They reject all signals with frequency greater than a few kilohertz. So I need to get me an AC power line filter to add to that. That's what I was trying to think of. Ferrite chokes are also used to reduce RF current on the outside of shielded audio, microphone, and computer cables. If you've got a computer at home, you probably seen one of the power cords that's got a little round black thing on the power cord, and that's what that is. It's a ferrite choke trying to prevent radio signals. Here's some good examples. This is a toroid. And you can wrap your wire through it like that, and that will help minimize. These are the little chokes that you can snap onto the power cord. And it's a ceramic magnetic material used to make choke filters and suppress the radio frequency interference. So there's different things that you can do to minimize the radio frequency interference from appliances in your home. Another thing you need to watch out for is the little power bricks, like the power bricks that charge your phone, run other displays in your home. Like if you have the Amazon devices, like I do, I have one sitting over to my left here, so I won't mention the A word that activates her, but she has a little power brick, and those power bricks can go bad, and they can provide radio interference if you're using your radio. So you have to sometimes go through your house and go on a hunt. You might have to take your little HT and see if you can pick up the frequencies and find out what device is causing the radio frequency in your home. I've even gone as far as turning off the breakers to individual rooms in my house, trying to find out what the source of interference is. Interference from amateur transmissions. You'll run into this once you get into your general and you're out using your radio. The most common causes of RFI from your transmissions are fundamental overload, harmonics, and spurious emissions. Very strong signals may overwhelm a receiver's ability to reject them. This is called fundamental overload. You may have somebody that may not be too close to you, or they may, and they're running a power amplifier, and you notice that they're on your display on your radio, their signals 3 inches wide. It's not really that wide, but you know that they're taking up a lot of the bandwidth in the particular band that you're on. Consumer equipment is often unable to reject strong signals outside the bands it is intended to receive. So we're talking like AM, FM radios. If you're using your ham radio, you may overpower somebody that's close to you with a small radio. A high-pass filter can be connected to an antenna input of FM and TV receivers to reject strong frequency signals from an amateur HF signal. This would come into play if you live close to somebody. Say your neighbor, his house is real close to yours, and you're transmitting on your ham radio. They may notice distortion in their FM radio, or they may actually see the TV vibrate. The picture might vibrate as you're talking on your radio. So you may have to find a filter and put it on their TV. Broadcast reject filters attenuate signals from nearby AM, FM, or TV broadcast stations. So if you live near a known AM or FM radio station or even a TV station, you may have to get a filter and put on your radio to keep those signals from interfering. Harmonics, spurious emissions, and leakage. Every transmitter's radio output signal contains weak harmonics of the desired output signal and other spurious emissions that can cause interference to nearby equipment. A low-pass or band-pass filter can be installed at the transmitter's connection to the antenna feed line to prevent harmonics. And when we, our club goes to set up and we compete like in winter field day or summer field day, we're going to use band-pass filters to keep from interfering to stations that are 10 to 15 feet from each other, because we'll be on different bands, but because we're so close, that radio frequency can be picked up by an amateur radio, even if they're not on that frequency. Leakage is another source of interference. The most common cause of leakage is a faulty coax connectors on the cable feed line. If you don't have your coax connectors tight to the radio and to the antenna, you may have leakage that can be picked up. Be sure the connectors are installed correctly and attached tightly. Good practices in your station. Regardless of the source, you can reduce or eliminate much of the interference by making sure your own station follows good amateur practices for grounding and filtering. Make sure your station is in good working order with appropriate grounding, filtering, and good quality connections. Use shielded wire and shielded cables to prevent coupling with unwanted signals and undesired radiation. Be sure to connect the shield properly and eliminate interference to your own home appliances and televisions first. All right, RFI and your neighbors. We've talked about this briefly. Start by making sure it's really your transmissions that are causing the problem. Sometimes the problem may be from the cable TV company. They may have a loose connection up on the utility pole, and that may be what is causing the interference. Another time it could be the electrical utility company. A transformer goes bad on a pole, and it's causing all kinds of interference. You could be picking it up. Your neighbor could be picking it up. Your neighbor might be blaming you when, in fact, it's the utility company. So you kind of have to play around and search out where the problem's coming from. Offer to help determine the nature of the interference. If you are the recipient of the interference, make sure your station meets the standards of good amateur radio practice and offer help to determine the source of interference. If you narrow it down to the utility company, let's say it's the electric company and they've got a bad transformer, you can call and let them know, hey, I'm an amateur radio operator and my station has picked up interference, and I've been out in the neighborhood and I found this transformer is throwing off RFI, and could you send somebody out to check it? And they're supposed to send somebody out to check that interference. So, and a lot of times, if they do find that it is their device that's causing the interference, they'll replace it with one that doesn't. You may have to politely explain to the neighbor that FCC rules prohibit them from using a device that causes harmful interference. And I will tell you that's a test question there. Be diplomatic in dealing with your neighbors. You can't throw around that, hey, I'm a ham radio operator and you can't do this. You've got to work with them if they're causing the interference. Same thing with the utility company. You need to work with them and ask for their help and say, "Hey, can you guys come out and help me?" All right, practice questions. Which of the following conductors is preferred for bonding at RF? Is it copper braided removed from the copper braid removed from the coaxial cable, steel wire, twisted pair cable, or a flat copper strap?
D.
It's going to be D, flat copper strap. What is a symptom of RF feedback in a transmitter or transceiver? Excessive SWR at the antenna connection. The transmitter will not stay on the desired frequency. Reports of garbled, distorted, or unintelligible voice transmissions. Frequent blowing of power supply fuses.
B.
It's going to be
C.
C. Reports of garbled, distorted, or unintelligible voice transmissions. Which of the following could you use to cure distorted audio caused by RF current on the shield of a microphone cable? A band pass filter, a low pass filter, a preamplifier, or a ferrite choke?
D.
It's going to be D, ferrite choke. All of these would go in on the antenna, somewhere between the antenna and the radio. And this preamplifier would not be something that would filter out radio frequencies. Which of the following can cause radio frequency interference? Fundamental overload, harmonics, spurious emissions, or D, all of these choices are correct?
D.
It's going to be D, all these choices are correct. Now, if you're not sure, I know spurious emissions we talked about, harmonics we talked about, the fundamental overload we actually talked about, but let's say I didn't remember that, but I recognize these two. If you get two of the three and then all of these choices are correct, you know it's going to be correct. So the answer is D. What would cause a broadcast AM or FM radio to receive an amateur transmission unintentionally? So we're talking about a radio, just a standard little AM, FM radio, and it's going to, why is it receiving an amateur radio transmission? The receiver is unable to reject strong signals outside the AM or FM band. The microphone gain on the transmitter is turned up too high. The audio amplifier on the transmitter is overloaded. The deviation of an FM transmitter is set too low. Which one?
A.
A. The receiver, the little AM or FM radio, cannot reject the strong signals outside of that band. So the answer is going to be A. How can fundamental overload of non-amateur radio or TV receiver by an amateur signal be reduced or eliminated? I want to move this down where I can see. How can fundamental overload of a non-amateur radio or TV receiver by an amateur signal be reduced or eliminated? Block the amateur signal with a filter at the antenna input of the affected receiver. Block the interfering signal with a filter on the amateur transmitter. Switch the transmitter from FM to single sideband. Switch the transmitter to a narrow band mode. So what this is saying here, you're getting an overload. You're picking up a signal on a non-amateur radio, such as an AM, FM radio, or a TV receiver, and you're getting that from an amateur signal. How can you reduce or eliminate it? And the answer is going to be A. I saw block, but you're going to block the amateur signal with a filter at the antenna input of the affected receiver. So you need a filter there. The answer is A. All right.
That's a high pass filter.
Pardon?
I'm so sorry. That's a high pass filter.
It could be. Yeah. It depends on the affected device. Which of the following can reduce overload of a VHF transceiver by a nearby commercial FM station? So you have a 2 meter radio and you're picking up commercial FM on it unintentionally. You can so how do you reduce it? Installing an RF preamplifier using double shielded coaxial cable, installing bypass capacitors on the microphone cable, installing a band reject filter. So you're trying to reduce overload of your transceiver by a commercial FM band station. So the answer is going to be you're going to put in a band reject filter. You want to try to reject that coming into your radio. So the answer is D. What should be the first step to resolve non-fiber optic cable TV interference caused by your amateur radio transmission? So if you have a fiber optic cable, it's not going to be a problem because it's not going to pick up radio signals. But a non-fiber optic cable, which is, in the olden days, it was like coaxial cable used in amateur radio. So what should be the first step to resolve that cable TV interference? Add a low-pass filter to the TV antenna input. Add a high-pass filter to the TV antenna input. Add a preamplifier to the TV input. Be sure all TV feed line coaxial connectors are installed properly. So the first step, what would you do?
D,
D, you're going to make sure everything's connected properly. Make sure the connectors are tight and where they should be. So the answer is D. So don't all overthink it. Try to keep it as simple as possible. Excuse me. So the answer would be D. Which of the following is a reason to use shielded wire? To decrease the resistance of DC power connections, to increase the current capability of the wire, to prevent coupling of unwanted signals to or from the wire, to couple the wire to other signals. Well, you're wanting to prevent unwanted signals. You want to shield them from the wire, so it's going to be C, unwanted signals. So by using shielded wire, you prevent the wire from picking up unwanted signals. Which of the following actions should you take if a neighbor tells you that your station's transmissions are interfering with a radio or TV reception? Make sure your station is functioning properly and that it does not cause interference to your own radio or television when it's turned to the same channel. Immediately turn off your transmitter and contact the nearest FCC office for assistance. You can eliminate that one immediately because there's no local FCC office. Install a harmonic doubler on the output of your transmitter and tune until the interference is eliminated. I have no idea. This is a distractor question. And D, all of these choices are correct. So we know these two are automatically eliminated. We know that one's automatically eliminated because there's not a FCC office near you. So the answer has to be A. You want to make sure all your equipment is functioning and does not cause interference to your own radio. What should you do if something in a neighbor's home is causing harmful interference to your amateur station? Work with your neighbor to identify the offending device. Politely inform your neighbor that FCC rules prohibit the use of devices that cause interference. Make sure your station meets the standards of good amateur radio practice. So I bet the next one's going to be D. All these choices are correct. So you want to work with your neighbor to identify the offending device. You want to politely inform them, hey, FCC rules prohibit devices from causing interference. And number one is you want to make sure your house is in order and you're good amateur radio practice. So this one will be D. All the choices are correct. Now, I'll tell you another that I found in my experience that causes radio interference. I have security cameras around my home, and they have a little, I've actually had the power supply to the security cameras go bad, and it caused radio interference. But now, when I say it went bad, the security cameras worked fine. It was just throwing off RFI that was interfering with me operating the radio. And then I've had a security camera. It was working fine, but it actually something was malfunctioning in it, and it was throwing off radio frequency interference. So that's just how crazy things can be. So D, all these choices are correct. Let's talk about radio frequency exposure. With its relatively low frequency, RF energy is non-ionizing radiation. So it's not like a nuclear type radiation. It's not going to cause you harm. It's non-ionizing. RF radiation is not the same as ionizing radiation from radioactivity because the energy in signals at radio frequencies is far too low to cause an electron to leave an atom. It can't cause genetic damage. Per FCC rules, the station licensee is responsible for ensuring that no one is exposed to RF energy above the FCC exposure limits. Heating as a result of exposure to RF fields is caused by the body absorbing RF energy. Microwaves, perfect example. We use them every day. We heat food with them. We don't want those same microwaves pointed at our neighbor, heating up the neighbor. That's not a good practice. Absorption varies with frequency because the body absorbs more RF energy at some frequencies than others. So this is a test question. RF burns can be eliminated by proper bonding techniques and by preventing access to an antenna. This is especially you want to be aware of when you're out operating in a park and you're activating as from POTA. If you see somebody coming up wanting to know what you're doing, it's a good idea not to continue transmitting, because if somebody walks up and grabs the wire, the antenna, they could get a radio burn, and you don't want that happening. A lot of times I went to the Dollar Tree and I bought these little orange cones, like little traffic cones, and I put them around my antenna just to warn people, by the color, maybe you shouldn't go near that. But a lot of times I want people to come up and see what I am doing, but I also want to make sure that they're safe and that nobody gets a radio burn. All right, here's a chart on the power density and frequencies. I'm not going to go over that a whole lot. I don't think there's a question that asks anything specific about the frequency. There may be, but let's go on. Exposure limits refer to the previous slide. People in controlled environments are aware of their exposure and can take the necessary steps to minimize it. People in uncontrolled environments are not aware of the exposure. Areas open to the general public or your neighbor's property, for example. Frequencies at which the body has a high absorption rate are from 3 to 1500 megahertz. That was on the graph. So 30 to 1500 megahertz. That is, so you want to pay attention to that. Those frequencies is where the highest absorption rate can occur. Averaging and duty cycle. MPE limits are based on averages, not peak exposures, allowing exposure to be averaged over fixed time intervals. Transmitters only generate RF for a fraction of the time they operate. You're only going to get that radio frequency when you transmit. they receive or sit idle the remaining time. So that's why you're going to average it. It's not like number one, if you key your microphone and you hold that transmission open, most transmitters have a timeout feature and they'll stop transmitting after usually 2 to 3 minutes. So you're not always transmitting, you're listening or sitting idle most of the time. This lowers the duty cycle of the emissions. The ratio of transmitted signals on the air time to the total operating time. Duty cycle must be considered when you're evaluating exposure. Because the signal is only present for about half of the time, 50% duty cycle, the signal power can be twice as high and still have the same average power as transmitting continuously with 100% duty cycle. All fixed stations must perform an exposure evaluation. 3 ways to make this evaluation using the technique outlined in the FCC Office of Engineering Technology Bulletin 65. Measure the power density of your transmissions. Make computer models of your station. You only need to evaluate if you change equipment in your station that affects your output power. And here's a web page that you can go to. It's on the ARRL FCCRF exposure. So you can, if you just go to arrl.org and then search for RF exposure, you can see the regulations there. You'll need information on the RF signal frequency and power level, distance from the antenna and the antenna's radiation pattern. Most of the radios you're going to be running will be at 100. I only operate at 100 watts on my radio, so I'm not going to be as concerned about this as somebody that's got a amateur radio station and they have an amplifier on there and they're running at 1,500 watts. That's a big difference. So I would definitely want to make sure that I've got my station set up and I'm following the proper exposure regulations. Okay, exposure safety measure. One is locate your antenna away from where people can get close to them. You don't want people coming up and touching them and you're in the house transmitting. You want it to be out of reach. That's why you want your antenna to be way up high. Like even when I'm operating on a POTA, I'll try to get my antenna out of reach, especially so small kids can't get it or adults. I try to go up probably 8-10 feet off the ground. Raise the antenna. Avoid pointing beam antennas where people are likely to be. So if you've got a Yagi antenna and you want to aim it, you want to make sure you're not aiming it at your neighbor's house. You want to move it where that beam won't interfere with someone's home. Use a lower gain antenna to reduce radiated power density or you reduce your transmitter power. Limit the average power of your transmissions. You may have your radio or your amplifier, you may be wanting to run 1,500 watts, but if you're causing interference, you may have to drop it back. Place mobile antennas on the roof or trunk of the car. That maximizes shielding. Use a remote microphone to hold a handheld transceiver away from your head. One of my radios, most of them, like the one I have here, I don't know if I can get it to show up or not, but this one, it's a little HT. I could get a remote microphone for it, but it's just easier to use it holding it in my hand. But if you're worried about that, a lot of the radios come with a micro, or you can buy a microphone that you can either attach and hold the handheld away, or I have another handheld that actually has a Bluetooth microphone that I really like. All right, some practice questions. And we're doing pretty good. We're over halfway done here. What type of radiation are radio signals? Gamma radiation, ionizing radiation, alpha radiation, or non-ionizing radiation?
Ionized, the D.
D, non-ionizing radiation. Why do exposure limits vary with frequency? Lower frequency RF fields have more energy than higher frequency fields. Lower frequency RF fields do not penetrate the human body. Higher frequency RF fields are transient in nature. The human body absorbs more RF energy at some frequencies than at others.
Human body absorbs more RF energy at some frequencies than at others.
That is correct. Answer D. What hazard is created by touching an antenna during a transmission? Electrocution, RF burn to the skin, radiation poisoning, or D, all these choices are correct. Well, we know it's not radiation, so C and D are gone. You're not going to be electrocuted, so the answer is B. You can get a radio frequency burn to the skin. How does RF radiation differ from ionizing radiation, radioactivity? So when you see ionizing radiation, you're thinking of radioactivity. RF radiation does not have sufficient energy to cause chemical changes in cells and damage DNA. RF radiation can only be detected with a RF dosimeter. RF radiation is limited to a range of a few feet. RF radiation is perfectly safe.
A.
It's going to be A. This one could also, I disagree. It's not perfectly safe, but if you treat it with respect, you're okay. But the answer is going to be A. Who is responsible for ensuring that no person is exposed to RF energy above the FCC exposure limits? The FCC, the station licensee, anyone who is near an antenna, the local zoning board.
Station licensee.
It's going to be B, whoever's operating, whoever that station is licensed to. At which of the following frequencies does maximum permissible exposure have the lowest value? 3.5 megahertz, 50 megahertz, 440 megahertz, or 1296 megahertz? Lowest value, permissible exposure have the lowest value. That one is going to be B, 50 megahertz. How does the allowable power density for RF safety change if the duty cycle changes from 100% to 50%? It increases by a factor of 3. It decreases by 50%. It increases by a factor of 2. There is no adjustment allowed for lower duty cycle.
C.
D,
I think I heard C. It increases by a factor of 2. So if the duty cycle changes from 50%, the RF safety will go up from 100% to 50%. The RF safety goes up by 2. So you think of multiplying 2 times 50, you get 100. You're not operating at 100% of the time. You're only operating at 50% of the time. So that change will go up by a factor of 2. Why is duty cycle one of the factors used to determine safe RF radiation exposure levels? It affects the average exposure to radiation. It affects the peak exposure to radiation. It takes into account the antenna feed line loss. It takes into account the thermal effects of the final amplifier. We can take C and D off.
this must be A.
It's A. It affects the average exposure to radiation. So the answer would be A. What is the definition of duty cycle during the averaging time for RF exposure? The difference between the lowest power output and the highest power output of the transmitter. The difference between PEP and average power output of the transmitter. The percentage of time that the transmitter is transmitting. The percentage of time that the transmitter is not transmitting. So think of duty cycle. So it's going to be C, the percentage of time that the transmitter is transmitting. What factors affect the RF exposure of people near an amateur station antenna? Frequency and power level of the RF field, distance from the antenna to a person, radiation pattern of the antenna. D, all these choices are correct. So what factors affect the exposure? And we know it's this one, how close you are to the antenna, and the pattern that the antenna emits. So the answer here is going to be D. All these choices are correct. Which of the following is an acceptable method to determine whether your station complies with FCC RF exposure regulations? Calculations based on the bulletin, calculations based on computer modeling, by measurement of field strength uses calibrated equipment, or D, all these choices are correct.
D.
Going to be D.
Yeah.
So
Bulletin.
So,
One of them.
so I know this one. We talked about the bulletin. We talked about computer modeling. So I got two of them that I know are right. So it's going to be D. All these choices are correct. How can you make sure your station stays in compliance with RF safety regulations? By informing the FCC any changes in your station. FCC don't want to know that. By reevaluating your station whenever an item in the transmitter or antenna system is changed, by making sure your antennas have low SWR, or D, all these choices are correct.
B.
The answer is going to be B. Anytime you make a change to your station, you put in a new radio or you change antennas, you want to evaluate to make sure you're in compliance. Now, if you're like me, I live way out in the country. My nearest neighbor is about half a mile to a quarter, 3/4 of a mile away. I don't have to worry about interfering with them, and I'm only running at 100 watts maximum. Which of the following actions can reduce our exposure to RF radiation? Relocate your antenna, relocate the transmitter, increase the duty cycle, or D, all these choices are correct. Reduce exposure.
Relocate antennas.
Relocate your antenna. Your exposure to the radio frequency is going to come from the antenna. If it's coming from the transmitter, you've got feedback coming from the antenna back to the transmitter. So that answer is not correct. Increasing the duty cycle means you're transmitting more. So that's not correct. And so you know this one's not. So it's going to be relocating the antenna. All right, mechanical safety, antennas, and supports. Now, if you're young person, and you're going to be building an antenna and you're going to be climbing, I think this is a section that's going to talk about this. Make sure your plans satisfy local zoning codes and covenants or restrictions in your deed or lease. So you don't want to put up an antenna until you've checked with especially if you're in a neighborhood. You want to make sure that you follow all the zoning codes, HOAs. If you're in an HOA, good luck. Although ARRL is trying to get a federal law passed that will allow amateur radio operators to put up antennas so they can operate in an emergency. So you want to follow all local codes and things. Place all antennas and feed lines well clear of power lines. You don't want your antenna erected close enough that in a windstorm it blows it down over the power line, and you don't want it close enough to a power line as you're trying to put it up. If it gets away from you and it falls on the power line, you could be killed. So you want to make sure you're clear of all power lines. So make sure when you're putting up an antenna, you're not near the utility lines. A good guideline is to separate the antenna from the nearest power line by 150% of the total height of the tower or mast plus the antenna. And I believe that's a test question. A minimum of 10 feet of clearance during a fall is required. So if your antenna were to fall over, it would have to be 10 feet back from the power line. I wouldn't want mine that close if it were to fall over. Never attach an antenna or guy wire to a utility pole. You never know when the utility company is going to have need to climb that pole, so you don't want to interfere with the utility pole by putting an antenna or attaching a wire to it. Grounding rules for antennas and supports must be followed according to your electrical code. Towers should be grounded with separate 8-foot long ground rods for each tower leg, bonded to the tower and to each other. Place safety wire through any turnbuckle used to tension guy lines, and that prevents the turnbuckle from loosening due to vibration and twisting. You've got a guy line running up holding a tower. The wind's going to rock that tower a little bit. It's going to be moving back and forth. And if you don't put something in a turnbuckle, especially if you got a guy wire, that would keep it from coming loose. So you want to put a safety wire through it. All right, tower work and climbing. So if you're a young person and you want to climb towers, let me know. I may want to hire you at some point because I'm too old to do it anymore. Climbers and ground crew should wear appropriate protective gear anytime work is underway on the tower. And there are some people that make pretty good money climbing towers and fixing them for ham radio operators. Be sure to get sufficient training on safe tower climbing techniques before beginning. Use appropriate tie-off to the tower at all times, and always wear an approved climbing harness and a hard hat, I'm going to say. Never climb a crank-up tower supported only by the cable that supports the sections. You want to make sure those sections are locked off. Double check all climbing belts and lanyards before climbing. Make sure all ropes and load-bearing hardware are in good condition before placing them in service. Use a gin pole so that you do not have to hoist things directly. And double check the latest weather report. You don't want to be up 50 to 100 feet in the air and the thunderstorms rolling in on you. That wouldn't be good. And never climb alone. It's just not safe. All right, here are some practice questions. Which of the following is an important safety precaution to observe when putting up an antenna tower? Wear a ground strap connected to your wrist at all times. Insulate the base of the tower to avoid lightning strikes. Look for and stay clear of any overhead electrical wires. Or D, all these choices are correct.
C.
C, look for and stay clear of any overhead electrical wires because that's the most dangerous part of putting up a tower is people don't, or even like in my case, I work on a farm and farmers don't pay attention when they've got a tall piece of equipment and they drive under a power line and it causes all kinds of problems. So you want to always look for any overhead electrical utility lines. So the answer is C. What is the purpose of a safety wire through a turnbuckle used to tension guy lines? Is it to secure the guy line if the turnbuckle breaks, prevent loosening of the turnbuckle from vibration, provide a ground strap for lightning strikes, or provide the ability to measure for proper tensioning?
E.
B, to prevent the turnbuckle from loosening up from vibration. What is the minimum safe distance from a power line to allow when installing an antenna? Add the height of the antenna to the height of the power line and multiply by a factor of 1.5, the height of the power line above the ground, a half-wave length of the operating frequency, or enough so that if the antenna falls, no part of it can come closer than 10 feet to the power lines.
D.
D.
It's going to be D. So that if it were to fall, no part of it can come closer than 10 feet. And when we say no part, that means the pole and the antenna itself. So the answer is D. What is a proper grounding method for a tower? A single 4-foot ground rod driven into the ground no more than 12 inches from the base, a ferrite choke, connected between the tower and ground. A connection between the tower base and a cold water pipe are separate 8-foot ground rods for each tower leg bonded to the tower and to each other.
D.
Se- Separate
D.
8 foot.
D,
D. You're going to have 8-foot ground rods. They're going to be bonded to the tower legs, one for each tower leg. So if it's a 3-legged tower, it's going to have 3 8-foot ground rods. They're going to be bonded to the tower, and then you're going to connect the ground rods to each other. So the answer is D. Why should you avoid attaching an antenna to a utility pole? The antenna will not work properly because of induced voltages. 60 hertz radiation from the feed line may increase the SWR. The antenna could contact high voltage power lines, or D, all these choices are correct. Now you're thinking of a utility pole, electrical pole.
I'm gonna say C.
C,
That antenna could contact high voltage power line.
That is correct. The answer is C. You could contact high voltage power lines. You can kind of knock that one out. So that's even if you're guessing, you can take that one out, and that automatically takes that one out. So it's going to be the most easy thing, the most logical thing. You could come in contact to high power lines. What is required when climbing an antenna tower? Has sufficient training on safe tower climbing techniques. Use appropriate tie-off to the tower at all times. Always wear an approved climbing harness. And D, all these choices are correct.
D,
It's going to be D. All these choices are correct. Now, appropriate tie-off to the tower, I'm just going to mention this. If you've got a climbing harness on and you watched anybody climb a tower, they've got at least 2 separate tie-offs, and they're going to tie to the legs of the end of the tower, not to the rungs, if that makes sense. They're going to have at least one tie-off at each time, at all times will be attached to the tower as they're climbing. So the answer is D. All these choices are correct. Under what circumstances is it safe to climb a tower without a helper or observer? When no electrical work is being performed, when no mechanical work is being performed, when the work being done is not more than 20 feet above ground, or D, never.
D,
D,
Never.
never. That when you see utility workers working on power poles, even in buckets, but big bucket trucks, what do you see on the ground? At least 1 or 2 people on the ground, and they're watching. So they're observing. They're trying to make sure that that person in that bucket doesn't make a mistake. So you never want to work on anything above ground, on a tower by yourself. Now, do people do that? Yes. Is it smart? No. So you never want to work without somebody there in case, even if you fall, you want somebody there that's going to be able to call 911. Which of the following is an important safety rule to remember when using a crank-up tower? This type of tower must never be painted. This type of tower must never be grounded. This type of tower must not be climbed unless it is retracted or mechanical safety locking devices have been installed. Or D, all these choices are correct.
C,
It's going to be C. The tower must not be climbed unless it's retracted or mechanical safety interlocking devices have been installed. So the answer is C. And folks, that's it. We're at the end of our material. I want to thank each one of you for hanging in here with me and let me teach this class. Let's talk a little bit about what will take place. How many of you think you're going to do the test online, or do you have a club nearby that you want to take the test?
I'm gonna do it online.
Okay.
I'll also do it online if I can get an FRN number.
Okay. Jeff, what about you?
Probably the online It's a little ways off for here in Bowling Green. The closest one's Somerset and Russellville in a few weeks. So,
Yeah, and
so
well,
up.
there'll be one. I know there's another one here in Bowling Green. I think coming up in February. So I don't know if you want to wait that far out. I'll have to check my dates and see. Let me. I'm going to leave my share. Everybody can still see my screen, correct?
Mm-hmm.
All right. As I mentioned earlier before the class started, I work with a online team. I'm a VE for that online team. They have several VEs that work from all over the country, and we do testing on a regular basis. I could test every day, all day with folks if I had the time, but the way it's set up, they just send out a call, and VEs who can respond will respond and help conduct a testing session. But what you'll need in your testing session, you'll need two devices. You'll need your cell phone with a camera, hope preferably a smartphone like an iPhone or an Android, and you'll need a computer or a tablet, uh, an iPad or Android tablet to take your test. And you'll need to be in a room with by yourself. And what will happen is, as we're getting ready to administer the test, there'll be a team lead, and they'll ask you to take your iPhone and scan the room. And you can have only one piece of paper, and it has to be blank. And they'll look at that paper. They'll want to look at your desktop if you're working from a desktop computer. Believe it or not, the best place they recommend that you take your test is in a bathroom, because there's nothing there to cause any kind of distractions. You don't want to have any screens other than your computer screen, your tablet screen, and your phone. And what they will ask you to do is, if let's say you're taking your test on a computer, you can only have one screen on that computer that you're looking at. If you've got, like me, I've got two additional screens here. You'll have to cover them. You can't just unplug them. You'll have to cover them. If you've got a TV in the room that's in front of you or behind you, it will need to be covered. You can cover it with a sheet, towel. It just has to be covered where you can't see it. Like me, I've got on headphones. When you take your test, you can use the headphones up until time to start the test. And once you start that test, you have to take your headphones off. And then the phone is used to watch your computer screen. So there'll be a VE that's actually watching your phone watch your computer screen. A lot of times I do that. I'm the R3. So I'll say, all right, Joe, you need to move your phone a little bit closer to the screen. I can't see your computer screen. So you'll have to have that set up where your phone set up where the VEs can see your computer screen. So no additional paper. You will need a photo ID, such as your driver's license or a government issued ID. It will show your name and address and picture on it. Once you start taking your test, everybody mutes except you. You need to leave your sound on and your video on so we can hear. Nobody can come in the room while you're taking your test. So if your significant other comes in and says, hey, what's for supper tonight? While you're taking your test, we have to stop the test and ask you to reschedule. So you cannot have anybody in the room. So it has to be a quiet place, no distractions, or anything like that. No additional papers, just your ID. And if you want one sheet of blank paper, you can have that. If you need a calculator, it has to be on the device you're taking the test on. We have to go through and make sure that it's been cleared out. No other everything can be running on your computer, no other applications, only your browser of choice and Zoom are the two things. And when we get ready to administer the test, somebody will ask you to share your screen. We'll look at your computer, see what's running on your computer. If you've got something running other than those two items, your browser and Zoom, we'll ask you to quit out of those. No email, no messaging software of any kind can be running on your computer. So it just has to be your browser so you can take the test. Now, once you register, now let me show you how to find the session. If you want to take it where I can be part of it, you want to look for, let me see, we want to do remote. And this is who you're looking for, the WM7X test team. And if you notice, today's Monday, they run from 8 a.m. to 8 p.m. They need about 10 minutes to get us together. So if you decided you wanted to take your test today, the cost is $15. You'll need to pay by, I forget, but any kind of online payment like PayPal, Venmo, any of those types of payments. If you're used to using those, you can pay that, and they will get you set up, get you started to take your test. You'll need that FRN number. So once you register, you will be contacted by a member of the team. They'll ask you to pay. They'll verify stuff, and then they'll get us all together, and we'll take that test. Any questions on any of that? Am I clear as mud?
Pat, I'm going to jump off here real quick, but I want to thank you so much. It's been a great refresher course for me. I really appreciate it. Good luck, everybody, taking your test, and y'all have a good week. God bless y'all. Thank you, Pat.
Okay, you're welcome. Now, I want to show you one other thing. Is you'll be directed to examtools.org, and this is what it will look like. And I, as a VE, log into this. But if you're ready to take your exam, you're going to join an exam session. The team identifier will be WM7X, and then they will give you a PIN number. Then you join the session, and then that's when you start taking your test. And it'll be a series of multiple choice questions that just scroll up. You can just, if you're doing it from an iPad, you can just click on the answer and it moves to the next question. If you're using a computer, you can either click on the answer, A, B, C, or D, and scroll up, or you can type in the number A, B, C, or D, and it will automatically scroll up. When you get to the end of the test, which is 35 questions, there will be a button that will say grade exam, and then one of the VEs will grade the exam, and then under 30 seconds, you'll know whether or not you passed. So you'll see this. Let me go over here to this one. Show you this. This is if you want to go to WM7X.net, they've got a video up of what, and this is some of the guys that I work with online. All of these are VEs, but this gentleman right here, he's pretending to take his exam as a technician, and he actually missed one, and it about killed him. But to have to do that. But there's a video there that goes through some of the things that I've already talked about. So if you want to watch that, you can go to that. And then, like I said, if you want me, I'll be glad to sit in. I've already talked to Stephen. He's fine with me sitting in, and I'd be honored if you'd let me. But if you don't want me to, I understand because it's kind of nerve wracking. Uh, but my thing to you is, uh, I think every one of you are going to pass. But for some reason you get nervous and you don't pass. Don't give up. Try again. Go back to that ham study and make sure that you are hitting all the questions and you get that. You can see here, I've not used Ham Study for Technician, but you can see I've been playing with it. And so when I go in study mode, I think last week I was in 20%, and tonight I got on and was just answering the questions, and I'm up to 33. You want to make sure that this says 100%, and then you get this up to about 85%, you're ready to take the test. So shoot me an email, say, hey, I'm going to sign up and take the test. I'll be glad to join in on it. I try to. I'm busy quite a bit through the day. I have a grandson that I have to pick up from school. I actually take him to school and pick him up from school every other week. So I may not be able to sit in, but if you do it, say at 6:30 at night, I'll do my best to be here and sit in with you. Or if you want to get with me ahead of time, shoot me an email. Uh, I'll be glad to let you know when I'm available so I can sit in with you.
Sounds great. As soon as I can get my FRN, I would love to have you sit in. I
Okay.
just can't. I haven't been able to get every time I get in. I've tried both my phone and a compute like a computer, and it's said something about I can't remember,
Okay.
and but it's not worked. And so I keep trying every day, though, a couple times a day, and I'll keep trying until it'll let me.
All right. And Brittany, you bring up a good point too. The FCC, it's a government website. Government websites don't like tablets or phones. So when you pay your license fee, you'll need to use a computer. Uh, and Jeff mentioned Brittany too earlier when we were waiting to start the class that he just got his FCC a little bit ago. Was that correct, Jeff?
Yeah, and I tried Brittany and throughout the day, and it kept coming up with an error message, no explanation. And I found a part to their help desk part, and they were talking about certain parts being down, but it allowed me to get in, about an hour and a half before this class started tonight, and it just went through and didn't have any problems after that. So I think that they were having a site problem today, at least today.
Oh, great. I'll definitely try as soon as we get off here then. Thank you.
Okay. All right. I think that's all. That I can think of right now. If I think of anything else, I'll shoot out an email to you guys and let you know. But again, I appreciate you all hanging with me through this. It's been a lot of fun on my part. Uh, I truly enjoy ham radio, and I want other people to get in and have as much fun as I do. And so, if nothing else, we'll go ahead and we'll end the class. And thank
Do
you
you
again.
do, I'm so sorry to interrupt. Do you do general classes?
I'm going to. I haven't yet. I'll probably during November, the rest of November and December, work on the material. ARRL. This is not my material, by the way. I've used ARRL material, but I've added to it and tried to clean it up a little bit to where it fits my style, if that makes sense. But I will probably start a general in January and try to do it January, February, and we can do the same thing. We can test online. This group, that WM7X, we test up through extras. So amateur extras, you can get your amateur extra online too. So
Great. What would be the best way to look out for that general class?
um, I will send an email out to the tech class when I get it ready and let you know.
Thank you. Perfect. And thank you
Okay.
so much for all of this.
Well, thank you. I appreciate you all being here and hanging with me. So, good luck, and just let me know when you're ready, and shoot me an email, and we'll coordinate a time with Stephen and get you tested.
Thank you, Pat.
All right.
Thank you, Pat.
You're welcome. You all have a good night.
You as well.